Welcome to my lesson number 10 in my energy series. Today I'm going to be talking about efficiency. The word efficiency compares the useful output to the total input. And we can write this, the Greek letter eta. So we use this as the useful, it's a ratio, useful output energy divided by the total input. So it's a ratio. We can do this for energy. Same thing for power. We get the same number because energy, because the time just cancels out because power is the rate of change of energy. Output, that's useful because the energy is conserved, so the power input. The energy goes somewhere. The term here is useful. Something we can use, not just wasted energy. If we want to put that in terms of percent, what we would do is the efficiency, eta, is equal to the useful, I'll just put energy, going to be power, times the total input, and that's times 100%. So that converts it to a percentage. A lot of times we see that in percentages. So if we think of this in terms of like a machine, here's our machine, and we have a certain amount of energy coming in. So this is energy in, and then this is energy out. That's the useful energy out. Now this other energy that comes out of it, that's going to be the non-conservative, like the heat, vibration, sound, friction. These are all it's a wasted energy. We like machines that are 100% efficient, but they're not. So I've got a little machine here I want to show you, and we'll demonstrate this. Okay, turn it on. Now it's a rotary grinding wheel, and it produces really two forms of useful energy. One is the grinding process here, the little wheel. So I can grind on this piece of metal, and you can see it is removing metal. So it's doing something that produces a light. So that's the two useful forms of energy. But now there's a lot of wasted energy in here. The batteries inside here convert the chemical energy to electrical energy. It's not 100% efficient. The motor in here, we figured out about 80-85% efficient. That rotates the shaft, so we're losing power there. So the chemical energy is turned mechanical energy, which is turned into useful energy. This is the useful energy right here where I'm grinding. And then the light that helps me grind. Everything else is just a waste. So the efficiency on this, I don't know what it is, but it's less than 100%. Now let's look at an example. An electric motor receives 500 joules of electrical energy. It delivers 425 joules of useful mechanical energy. Find the efficiency. So we've got energy in, that's plugged into the wall. The electricity coming in causes the motor to turn. Goes over here to our belt, which drives I've got this as a saw wheel. Like I'm cutting wood again. That's a good example. So now what we want to do is we want to find the efficiency. So the efficiency, eta, is equal to useful out by total in, power, energy. So the useful out, we're told here is 425 joules. And the total energy in is 500 joules. Okay, so we take the ratio of that. Let's get our calculator out. Turn it on. Then we clear it. So we got 425 divided by 500. Enter. Okay, that's 0.85. So 0.85 or 85%. And this is pretty typical from an electric motor. They're usually 80-85% efficient. So that's a fairly realistic number. Now let's do a second example. A gasoline engine has efficiency of 30%, and that's fairly typical. They're using the 20 to 30, 40% range, depending on how efficient its design is, and they're not as efficient as electric motors. The fuel supplies 400 kilojoules of chemical energy. How much useful mechanical energy is produced? So in this time, we're given the efficiency in terms of percentage. We're given the total energy in, that'd be the gasoline in the motor. So we know our efficiency, eta, is equal to 0.3 or 30%. That's going to be the same, just dividing by 100. Now the efficiency is equal to out divided by in. That'd be the energy out, energy in. So we want to know the energy, how much mechanical energy is produced. So we want to know the output energy. Let's take that on the other side. So the energy out now is equal to this eta times the energy in. Now the energy in, we know, is 400 kilojoules, and the efficiency is 30%. So it's 0.3. We do our multiplication in the decimal format rather than the percent format. And then we have got 400 kilojoules, so that's 40,000 joules of energy. This is dimensionless, so it's going to be energy. We're going to get joules out. Get our calculator out again. Clear it, and we take 0.3 times 40,000. 1, 2, 3. Enter. So that's going to be 12 kilojoules of energy, and that's going to be the useful out. So if we do a little diagram of this, here's our gasoline engine. I'll put some little pistons on it, and I don't know, it looks kind of a little, I don't know what it is. This is our gasoline engine, and we've got the gas coming in here. So we've got 400 kilojoules coming in, and then we've got out going 12 kilojoules. So where did the rest of it go? It goes in the form of wasted energy. Your car motor gets hot, it vibrates, generates sound. You hear your motor revving up, it generates exhaust gas and friction, and probably something else too. But these would be the main, that's where most of the energy goes. And this is the wasted energy. So we put 40 kilojoules in, and we got out 12 kilojoules because our system is only 30% efficient. The rest of it goes in this form of wasted energy that we really don't need. It's not useful energy. Well, I hope you got something out of this video and learned about efficiency. And it's important to remember, one thing to remember is that nothing is 100% efficient, not at least mechanical devices. So I want to thank you for watching, and leave a comment if you need to.